This review is for the logarithm part of the test. Depending on the section you are in, you may also have additional sections that will be on your exam, so study appropriately. Now, the first 3 questions are actually from section 4.1, and all we're doing is evaluating these on the calculator. So by now everyone is familiar, so I'll let you put that into the calculator yourself. E to the 1 divided by 3 is 1.396. Remember, you're going to keep them out to 3 decimal places. Let's see, 3 to the square root of 2. When you plug that into the calculator, you should get 4.729. I'm rounding to 3 decimal places. And 0.002 to the 1 divided by 300 power. And again, by this point, as you're studying, everyone knows how to use their calculator. We taught and reviewed that in class with every single example. So here we are. Those are the first 3. Now, starting now, and for the rest of the review, I'm going to go ahead and move down. There's not enough room to work everything here. So I'll go to the end. Number 4, when we're asked to graph f of x equals 2 to the negative x power, I'm going to build 5 points as the directions indicate, or will indicate on the test. And these are the 5 points you'll build every single time. You'll plug those into your calculator, and I'll write the first one down. 2 to the minus 2 is actually 2 squared, which is going to be 4. 2 to the minus 1 will be 2 to the 1, or 2. 2 to the minus 0 will be 2 to the 0, or 1. 2 to the minus positive 1 is 2 to the negative 1, or 0.5. And 2 to the minus positive 2 is 2 to the negative 2 power, which is 0.25, or 0.3 for graphing. I will be providing you with the axis to graph on. But here I'm looking and I notice that 5 is our biggest number, so I'm going to do 5 units in every direction. We know all exponential functions graph exactly the same way, like the inside part of your hand. Negative 2 goes up to 4. Negative 1 goes up to 2. 0, 1, 1 to 0.5. And 2 to 0.25. To the right, it appears to be leveling off, and to the left, it appears to be increasing exponentially. Number 5, and again, make sure, as it says on your review, that you watch all of the examples that were provided for 4.4. You've already done the homework, so you have all of the practice you need. And you also have available to you video 4.4, and I would watch that again. And you should be perfect on logarithms. The first one on this review is 2 exponential functions set equal to each other. And I could make the bases match here, but the way that we talked about these in class is if we have 2 exponentials that are not equal to each other, don't match on the bases, you start by taking the natural log of both sides. Then you're going to pull the exponent out in front, both sides, and then you look at that and you're thinking, okay, well, natural log of 3 is just a number. It is 1.099, and the natural log of 9 is 2.197. I'm going to distribute 1.099 onto the x, onto the negative 2, and I'll distribute the 2.197 onto the x, and then onto the 4. Now I will move all the constants to the right. Make sure you change the sign when you do that. All the x's to the left, or whichever direction you want to. and combine. Here, I'm going to get negative 1.098 x's are equal to 10.986. After dividing both sides by negative 1.098, you get 10.005. If you do it a different way, you'll actually get exactly the number 10, and as long as you show all of your work, it will be counted correct. Here's number 6. Number 6 is 5 to the x power is equal to 1.4. As we talked about in class, it's important to know how to identify them. This is an exponential function. I don't know how to deal with that, so I quickly convert it to a log form. Log base 5 of 1.4 is equal to x. Once I have two numerical values on the logarithm, I know I can use the change of base formula. It will be the natural log of 1.4 over the natural log of 5. Go ahead and put that into your calculator. And I got 0.209 is what my x is equal to. Number 7, we have 400 e to the 0.005x equals 1600. I'm going to start off by trying to get the exponential function all by itself. So I'm going to divide both sides by 400. Okay, as soon as I have the exponential function isolated, this is the special exponential function. So I'm going to take the natural log of both sides. On the left, the natural log and the e cancel, so the 0.005 drops straight down. On the other side, the natural log of 4 is the number 1.386. After dividing both sides by 0.005, we're going to end up with x is equal to 277.259. On number 8, we start off, we're going to notice that it is an exponential quadratic, so I'm going to open up my two parentheses. So the factors of e to the 2x are in the center, so they are e to the x and e to the x. Factors of 5 that add or subtract up to be negative 6 will be negative 5 and negative 1. I'm going to set each one of those factors equal to 0. Move the 5 over, we get e to the x is equal to 5. That is another special exponential function. To get rid of the e, I'm going to natural log it. If I do it to the other side, I do it to one side, I do it to the other. On the left, the natural log and e cancel each other out. And to get our final answer, the natural log of 5 is 1.609. For this one, I'm going to move the negative 1 over to the other side. This is also a special exponential, so I'll take the natural log of both sides. On the left, the natural log and the e cancel, so we get x equals. The natural log of 1 is 0. And as we know, it is okay to get answers of 0. Number 9. If we have log base 6 of 4x minus 1 equals 3. If a single log function is not doing it for us, we're going to convert it to exponential. The base to the power equals the thing. 6 to the third power, we know, is 216. And now it's just a linear equation. I'll start by moving the 1 over to the other side. That becomes a positive 1, which totals 217. To solve for x now, I'll divide both sides by 4, and I'm going to end up with x is equal to 217 divided by 4, which is 54 0.25. Number 10, 2 natural log of 3x equals 8. Start by isolating the natural log. Since it is a single natural log equation, we get the natural log of 3x is equal to 4. To get rid of the natural log, I'm going to e both sides. On the left, the e and the natural log cancel, so I end up with 3x is equal to e to the 4th power, which is 54.598. Oops. After dividing both sides by 3, we're going to end up with x is equal to 18.199. Number 11 is log of x plus log of x plus 15 equals 2. If you have multiple logarithms, your first step will be to create single logs. Since they're both added, it will be the log of x times x plus 15. Now this one doesn't have a base. Well, actually it does. It's 10. So since I have a single log equation, I'm going to convert it to exponential. 10 to the 2nd power, or base to the power, will equal to x times x plus 15. Cleaning that up, I get 100 is equal to x squared plus 15x. That is a quadratic right on the verge. I'm going to move everything over to the same side and factor for time's sake. If you're allergic to factoring, you can use the quadratic formula. This factors into x plus 20 and x minus 5. So we'll get values of negative 20 and positive 5. For number 12, we get the natural log of x minus 4 minus the natural log of x plus 1 equals the natural log of 6. On the left, I have more than one logarithm, so I'm going to combine them into a single. That will give me the natural log of, and remember, positive logarithms give me numerators, negative logarithms give me denominators. After cleaning that up, I get a one-to-one function. Since the natural logs are equal, so must the bases be. We have x minus 4 over x plus 1 equals 6. Then I'm going to write them as a fraction. We can cross multiply and solve. We get 6 times x plus 1 equals 1 times x minus 4. That gives us 6x plus 6 equals x minus 4. I'm going to move all the x's to the same side. It's going to give me a total of 5 x's. When I move the 6 over to the other side, I get negative 10. After dividing both sides by 5, we get negative 2. Good luck on your test.